Professor, we are live. I am just sharing the YouTube live link in the chat and the WhatsApp group. But we are live, so you can please take over.
So you make me the host.
Sure, I am doing that.
All right. So a very good evening to all. 3 minutes past 9 o'clock, and we are going to start our meeting now. So as I mentioned in the group, this meeting is essentially going to address two things. One is we are going to give you the feedback regarding the design competency examination. We will share the model solutions. We will take up any queries regarding the DCE. And then there are some queries raised by some teams on WhatsApp, which will also be addressed. So the way we are doing is like this. I will now request our volunteer, Mr. Namanuddin, to share his screen and solve each of the questions that were asked.
Hello.
Yeah.
Good afternoon, sir. Good evening. So I'm going to share my entire screen. Just let me. Okay, can you see my screen?
Yeah, we can see your screen now.
Okay. Just a second. Okay. What are you seeing on my screen?
Yeah, we can see the question paper. Is it possible to remove this AI process backdrop right now? Or maybe not, because it's a PDF file.
Yes, it's a PDF file. I'm using the same question paper which we have given to them.
Okay, so please go ahead. Now, you have to show the model solutions.
Yes, yes. So I will take one by one. So question one by another. Okay, someone is trying something.
Yeah, don't worry.
Okay.
I will try to take care of that.
Okay. So I want to discuss with the participants if they want to open up and share their things like what they feel and how they felt the question paper is, the difficulty level and all. Because we have asked in the poll, but very few of them have answered that poll. So any one of you in the participants would like to say something at this point? Or should I go ahead?
I think you should go ahead right now.
Okay. So the first question tells about the design lift coefficient of NACA 23015. So it's a simple question. The basic objective of this question that the participants and the designer should be knowing about the airfoils. What are these? What these numbers signifies? So that comes from that thought, and it is simply this is the nomenclature of NACA airfoil, 5-digit airfoil, in which each digit represent a specific parameter. So in which L represent the first digit, which is 0.15. If we multiply it with the first digit of this airfoil series, then it will be giving the design lift coefficient, which was the question asked. So other parameters, the second digit has significant parameter, and the same for third digit and the last two digit for the maximum thickness. So the question asked was about design lift coefficient of NACA 23015. It is simply 0.15 into the first digit of the series, which is 2. So CL design will be 0.3. So, sir, are we going to take it like Q&A type,
No,
or
no, just
I
go ahead
should?
here. You are being very slow, Noman.
Okay.
Just go ahead.
Okay. So question 2 about the parabolic drag polar, which was shifted in the y-axis. So drag polar has the equation of CD equals to CD naught plus KCL square, but in this case it will be a little modified. So here is the modified drag polar equation. So the participants should have identified it, and then they can give the answers of the question number 2, first part and second part. First part is very clear. where this curve, red curve, is cutting the x-axis, that will be the value of CD naught, not the minimum one. And to calculate the induced drag factor, they have to use this equation in which all the parameters can be read about from the graph, and they can calculate the value of k, which will be coming out at around 0.0246. So it will be nearby of 0.024, 23, 25 something. If you select other any other point on the graph, I have chosen 0.04 and zero point 0.7. So if you use any other points on the graph for CD and CL, then you will get the value of k in the ranges of from 0.023 to 0.027. So that is has been taken care by the evaluation committee. Question number 3 is a simple question about the first part. A part is very simple about the geometrical calculations. So some of the geometry has been shown in the figure itself, and you have to calculate these 6 parameters out of this geometry which is shown in figure 2. So these are simply formula or like geometrical based only. So for wing reference area, it is nothing but two trapezoid joined together. So here you can see the wing planform area. In the wing reference area, you have also considered this hashed area. So you have to consider two trapezoidal area, which is calculated by semi wing span by 2 into parallel sides, sum of parallel sides, and these are the two trapezoids, so multiply by 2. So this will comes out as 48.125 meter square. For the wetted area, so for this thing here, it can be seen it is a mid wing
Please,
configuration.
please zoom inside. Zoom in the top view. Thank you.
Yeah. So here we can see in the front view, it can be seen that the wing is going through the fuselage, and see, yeah, from here also, from the side view, you can see the wing is here. So it is going through the fuselage. So that way, wetted area will have to minus this hashed area. So when we minus this area, so the answer is for the wetted area, uh, wing reference area into 2 multiplied by 2 and minus that hashed area which is going inside the fuselage. So that should be minus. So wetted area comes out as 91.45 meter square. For the wing aspect ratio is simply b square by s. We have given b in the figure as we have calculated. So aspect ratio is simply 25.45. Taper ratio nothing but the CT by CR. I think both of them have been given. Yeah, CT and CR both are given in the figure. So taper ratio is 0.375. For the mean aerodynamic chord, we have taper ratio, we have root chord. So mean aerodynamic chord can be calculated by this formula. So which is coming out as 1.469 meter. For the Oswald's efficiency factor, there are several formulas available. So among them, you have to select the formula for E, which is acceptable for this range of aspect ratio, which is very high aspect ratio, which is around 25. So the simpler one, the simple formula of Oswald efficiency factor, which only considers aspect ratio, will not be acceptable here. So many of the teams have used that formula, and they have got the answer as 0.3, 0.4 something, which is wrong. Oswald efficiency factor is coming out by this formula 0.962. Here is a catch. If any one of you have used this formula, so we require the sweep of maximum thickness line. So we have to go back again to the geometry provided in the question paper. So this is the geometry of the airfoil, which is giving the maximum thickness at the midpoint. And we can see from the top view that mid chord is straight. If we see this wing planform, so the at the mid of the uh, uh, like mid chord will be the straight, giving the zero sweep angle. So if we put that angle in this formula, we will be getting Oswald efficiency factor as 0.962. Okay. Now coming towards the other part of this question, which is the B part, in which various values have been given, table has been given, and you have to calculate these required parameters. So in which you have this table given up to x location of CG from nose. So the the items which are highlighted in yellow color, which will be contributing towards empty weight of the aircraft. So this total weight of these yellow items by the maximum takeoff weight will give you the empty weight fraction. So the first question is about empty weight fraction of the aircraft. Second question is about weight fraction for loiter segment. So here uh, you have this mission profile. So loiter is only considering between the uh, point 2 and point 3. So you have to consider only this point to obtain this weight fraction for the loiter. So what you have to do for this, you have total fuel fraction, fuel weight by MTOW, maximum takeoff weight. Then from the definition, fuel weight fraction is nothing but 1 minus the weight fraction of the mission. So in this mission profile, from 0 to 5, so 5 W5 by W0. So in this will be, we have calculated 0.4. So we will keep here and we will obtain this W5 by W0. And W5 by W0 is nothing but the multiplication of all these things, the weight fraction in each segment. So from here, we have taken standard weight fractions. So we have taken these standard weight fractions for takeoff, climb, descent, and land. Apart from that, we have only remaining with loiter. So the weight fraction for the loiter can be calculated from this, and it is coming out as 0.6277. This is the weight fraction, fuel weight fraction for the loiter segment. Okay. The next question is about specific fuel consumption in SI units. So the specific fuel consumption is given in 20 milligram per Newton seconds, which should be converted in SI units. So this milligram should be converted to Newton, and Newton will cancel out each other, and it will be giving the answer is in per seconds. And for the endurance with full payload and full fuel, which is given in the question, you will use this formula for the, because it is provided in the question. It is a uh, it is a turbo. Yes. So this category of UAV, you have to use this formula for loiter segment to calculate the endurance, which is nothing but 1 by specific fuel consumption, L by D, and ln of the weight ratio of that loiter segment, but in reverse, like 1 by that weight fraction. So we have already obtained this weight fraction of W3 by W2. So we'll be using that weight fraction. L by D is given in the question, and SFC should be kept in this formula in units of per second to keep the units same on either side. So endurance should be like unit of time is seconds. So both of these things should be containing seconds. So which will give the value as this much of seconds. When we convert it into hours, it will be giving 23.75 hours, around 24 hours. Then maximum endurance, if we replace the entire payload with fuel, so what will happen in the weight breakdown table? So this fuel payload of 1000 kg will be replaced by another 1000 kg of fuel. Now the fuel has been changed from 5000 to 6000 kg. So when we take fuel as 6000 kg, fuel weight fraction will change, and accordingly loiter weight fraction will change. So apart from all the things will remains the same, only this fraction will change, and when we keep this fraction in this formula, then we will be getting the endurance as 31.13 hours. So roughly we are getting around 7 hours increment in the endurance if we are using 1000 kg more fuel and zero payload. Okay, next question is about the longitudinal location of CG from the nose of UAV. So this table is provided in the question paper, which include the longitudinal location of CG from nose. So we have taken the moments and added all the moments divided by maximum takeoff weight. So we will be getting the value of CG location in the longitudinal direction as 6.554. So these things have been done in the table itself. So all the moments have been generated here in kg or into meter. So the total moments will be this and the MTOW is this. So with this, we are getting the value of CG location as 6.554, and the static margin in percentage is nothing but the difference in neutral point and the center of gravity location. So this bar represent like it is divided, it should be divided by MAC. MAC we have already calculated from third A, and while we do these calculations, we will be getting static margin of around 13.34%. In the fifth question, uh, so this constraint diagram has been shown in which various points have been shown to you, in which the design area or the feasible area is only this above these all colorful area. So in this category, only F will be considered as the feasible point for the constraint diagram. Okay. The next thing about the tail configuration, it can be vary according to any team, any participant, or any designer. They, if they select any of the tail configuration, then they have to justify it why they are using it. The most common configuration is twin boom, and twin boom horizontal tail mounted over the vertical tail. This is the most common configuration used. But there must be certain justification around it why you are selecting any of these. So that's all from my side for the model solution paper, sir.
Okay, so thank you, Naman, for very nicely giving us the model solutions. Now I am going to open the floor to any participant who would like to comment on the question paper. Whether, first of all, is there anything that you don't agree with? Yeah, you don't have to worry. You can unmute yourself
मैं
and
कल
start
ही डाल
speaking.
दूंगा कल परसों
Sorry.
Somebody's mic is on by mistake. Somebody's mic is on by mistake. Naman, you can stop sharing the screen. We will come back to it,
Yes,
or
sir,
maybe leave it. Maybe leave it till somebody comments.
yes, yes. Not
If there are no comments, then we can go ahead.
okay. Is it stop?
No, wait. I'm sure there are some comments.
Yes,
I'm
yes,
sure some students would like to ask something, but let us not waste our time. Does any team or any mentor or anybody in the team, any leader, do you have any comments regarding the DCE?
Okay, someone has written in the chat box.
What is that? Formula for a UAV. Naman, what is your view?
One second, sir. Let me check in the question paper. I think we have mentioned it somewhere in the question that I was looking for at that time also. We have
Yeah,
removed
I
that
would like
statement.
to
Yes,
come in
yes,
here. Naman,
yes,
is it
yes.
okay?
Yes, 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 please.
Yeah. The question paper has a statement that this is a high bypass turbofan engine. Now, a turbofan engine is not a propeller-based engine. That's why the formula for jet engine has to be used.
Correct. It's clearly mentioned that it is a turboprop engine. Okay. Any other question?
Looks like there are no more questions.
I have a question with respect to evaluation.
Okay.
Because our team has not been shortlisted, was evaluation just based on the score only, as we did not the exact answers? No, the evaluation was not based only on the score. It was based on an evaluation of your competence. Okay, so we have looked at the answers that you have given, and when you have, if your team has given answers which are clearly indicating that you have not understood. For example, this question which came just now, about propeller efficiency. It is clear that you have not read the question paper carefully. Similarly, um, if you have not been able to really understand, the main problem that many people had was in the question related to the constraint diagram. They were not able to very clearly say that only the point F is feasible, everything else is infeasible, because in the constraint diagram, the feasible region lies when the wing loading and the thrust loading are meeting all the specified requirements. So we had people saying partially feasible, half feasible, feasible for that, feasible for this. I'm sorry. Okay. Uh, no, look, you have asked for any reconsideration. No, I think we will go through the question paper again. We don't have the time right now to do that. But if you are not able to appreciate, see, the one common mistake that many teams who have been discontinued is that they got an endurance of 300 hours, 200 hours, and did not really bother. Similarly, one particular team got an endurance of 1 hour, and they did not bother to say that an aircraft with 5,000, 6,000 kg of fuel, okay, how can that aircraft have an endurance of only 1 hour? Or how can you have endurance of 256 hours or 300 hours? If you get a wrong answer in design, you should first have the idea that this number is completely outrageous. If you had just mentioned that this number seems to be very outrageous, we would have considered. One or two teams have done that, and we have considered them. Okay. Next question anybody has? So Tanvi, I think you can now take over and answer the queries that some teams have asked. Send us the exact answer to all. No, I'm sorry. I have already asked Noman to solve the question paper. Okay, we are not looking at whether your number is 21.25 or 21.5. For example, if you have a wing of aspect ratio 25 and you get efficiency as zero point 0.2 or 0.1 or 0.06 in one case, that should ring a bell in your mind. Now, how can a wing with such a large aspect ratio have such poor Oswald efficiency? So this is not an examination to check your numerical competence. This is an examination to check your design competence. Design competence comes by solving the questions. It was clear that some teams have never solved a question of endurance, and for the first time they did it in the class, in the examination, and they got some outrageous number. They didn't bother. Yeah, so Tanvi, over to you.
Okay, thank you. I
In
have
between,
actually,
people can interrupt in between on the chat
yes,
or
yes. I would request all of you to continue putting your questions in the chat box. We'll come to them. Now, some people on the WhatsApp group have shared queries. I'm going to share those queries. There are 4 people who have shared queries. If you are here while the query is being addressed, please identify yourself. The first query was from Jensen Justice. The query was, is there any specific number of times the UAV should loiter around the detected target? The answer is no. In fact, the term loiter could be either in circles or in a straight line. So even that is not defined. Secondly, the question is, when deploying the neutralizer, does the UAV have to drop it directly above the target, or it can do deployment while on the move? The answer to this is yes, you can drop it directly above the target or deploy while on the move. The UAV is not required to stop and hover and then deploy the neutralizer. I hope this answers the question by this team. If somebody from this team is present here in the meeting, please, you can unmute yourself and ask any further queries if you have.
No, ma'am, we don't have any other further
Okay.
queries.
Okay, great. Thanks for confirming so quickly. All right, we'll move on to the next. This question came from Vedant on the group. These were not really questions. I mean, question 1 was just overview of stores, propulsion systems, and third was something about some L&T systems. Question 4 was a brief overview of different software tools that might be used. There are 2 or 3 tools that are available and which are easy to use in the aircraft design conceptual stage. There is OpenVSP, in which you can quickly make 3D CAD for an aircraft and do some aerodynamic estimation on those. Then there is a software called XFLR5, which also some of the teams have used for solving the DCE question paper. So primarily these 2 are quite easy. I'll repeat the names and in fact I'll also put them in the chat box after this. It's OpenVSP and
Tanvi, I have a small comment to make. This has already been mentioned in the overview webinar, which is available. They should see it.
true. That's true.
First webinar we gave, we have shown these tools. We have mentioned what they are. So they should. There are also other tools I have mentioned. So this is a repeat question. Please look at our first webinar. Recording is available on the YouTube channel, and you will get the answers.
Right.
Go ahead, Tanvi.
The next question was about some existing radical UAV concepts and their feasibility. I mean, this is something you can also look up on Google. Runway independent UAVs exist already. So I would encourage you, please do this. This is part of your literature survey, which is an important part of doing aircraft design. So if you have any, specific questions about this, about particular concepts, maybe we can address them in some future webinars. But I feel this question is very general right now. Now, the 6th question is about the iterative process of aircraft design. How do we go about it? See, you have given the DCE paper and you've already got a flavor of how the formulae are, how they are iterative in nature. So please use that. And the lecture notes have also been recommended in previous webinars. The videos are available online. So, I mean, there's enough GAN out there on how to go about it. So please use all these resources. If there's something specific you want to know, let us know and we can maybe have some webinars about it. Now, the last question is, when can we expect the session on Tejas aircraft by Mr. KP Singh? Answer, I'll request you to take that.
Yeah. So Mr. KP Singh is ready. He is keen to talk to us. We can do it very soon. Maybe some date can be recommended by people if there are certain windows to avoid. So in February we want to do a webinar. This one is not counted. This is a webinar of only the DCE. So in this month, in February, on some evening, we can request Mr. Singh, depending on his availability, to give this talk. Okay, so I'll be in touch. If someone has a particular window to avoid, you please tell us. We will try our best, but otherwise we will schedule on one evening based on mutual convenience of our volunteer team and Mr. KP Singh. It will be done. We would prefer in February itself. And it will be open to even those people who are not shortlisted. Don't worry.
Right.
So
Thank you,
there is
sir.
one suggestion from Vayugati member. Okay, 24th February. I'll keep it in mind. You can keep sending your messages through chat. See, I have one small issue. We have a dedicated WhatsApp group. We have a dedicated email address, but many people are not using it at all. They are not really using it for anything. They are just using it for some communication from our side. So I would not recommend that. Fine. Vayugati, I understand you have a midsem exam, 7 to 15. Okay, fine. We will try. We will note down these windows, and then we will find out what is convenient. Okay. Go ahead. Vedant, are you there in the meeting?
Anyone from this team is here and would like to ask anything further?
Okay, let's go ahead.
Right. The next question is by Raj Lakshmi. The first question is, to what extent should the avionics suite be detailed? Does this include block diagram interface definitions? It's a very good question. It shows that you have actually started planning for the problem statement. I like it. The answer to this is that yes, the avionics suite should be detailed to a preliminary design level, which means you have to include a block diagram that clearly shows what are the avionics, the primary avionics which are there in it. When I say avionics, the computing avionics, the sensors, as well as the power systems and any other electrical systems that you have on board, like motors, etc. You should also include any avionics which are specifically used for the engine and for deployment of the control surfaces, and also for the landing gear or whatever is your method of runway independence. Interface definitions, I'm not very clear. It's not required because this is an aircraft design exercise. But what the block diagram, the intention of the block diagram, I should say, is that you have to be able to identify the size, weight, and power requirement of the avionics suite components. The term for this is SWAP, SWAP, size, weight, and payload. So long as you are able to identify this, that should be more than sufficient. Please don't go into any further details like software, etc. It's not relevant to this exercise. Size, weight, and power is sufficient for you at this stage to identify how large your batteries should be, for example, and what is the dimensions, the length, width, height, how it fits inside the aircraft in your CAD diagram, and what is the weight of this, and what is the impact on the center of gravity of the aircraft. That's the intention of detailing out the avionics suite. The second question is, what is expected in uploading the mission plan during the pre-flight system check as defined in the ConOps? This is not in the scope of the NACDeC competition. There is no uploading or downloading or even a software like Mission Planner in this involved, because you're not going to build it, you're not going to fly it. This is an aircraft design exercise, so this is out of scope. The third question is, how should the primary design drivers be presented? We have given you some criteria that will be checked as part of your design reports at both the stages. Those primary design criteria the results need to be presented, and any assumptions that you made to reach those results should be clearly identified in your report. The fourth question is, what empirical approaches are expected for determining the aircraft's aerodynamic characteristics? The ones specified in the NPTEL playlist are sufficient. The answer is yes, this is sufficient. If you have something else from some other sources also, that is also most welcome. If you have some results from simulations like XFLR5, those are also encouraged. Please do not go into the domain of computational fluid dynamics. Don't do a CFD of your aircraft and come. There are no extra points for it, right? CFD will simply consume your time and your effort. It's a very time-consuming thing computationally as well as in terms of your time. So please don't get into CFD, use empirical approaches, and at the most use a simulation software like XFLR5 or OpenVSP. That's it. If you don't want to do that, the ones in the NPTEL playlists are more than sufficient. I hope this has answered all the questions. Rajlakshmi or anyone from her team, if you're present, please unmute yourself.
Yes, ma'am, that answers all of our doubts. Thank you.
Okay, great. The last set of questions was, I wouldn't call these questions. This is from Manya Bhartiya. Could you please also address the below topics, avionics and control system, propulsion systems, flight stability? Look, these are not real questions, but this is an opportunity if you want to unmute yourself and ask now. Anything specific about these things, please ask. Go ahead. Is anyone from the team present? From Manya Bhartiya's team? Okay. All right, that's it. These were the queries which we received. Would anyone else like to ask any more queries now? Now is the time you can unmute yourself and ask. I'm also going to look at the chat window. There is a question from Vayugati. Would the UAV need to loiter for imaging at any point? Like we understand that during flight, it would need to transmit a picture every minute. But would loitering be required for solely imaging and not only for payload dropping? See, the answer is you don't have to worry about it. Okay. The UAV will certainly have to loiter along the border, which has been defined for you. But it does not have to stop and hover around any point. So during the flight, please assume that the flight is continuously happening at the V loiter, which is the loiter speed of the aircraft, loiter airspeed. Please just consider that and go ahead. Don't worry about these things. The fact that you need to transmit a picture every minute, why was that specified? Because you don't need to have a very high spec camera. The camera is a small one and a very small antenna also to transmit home. Because we've also asked you to identify the avionics suite. So in the avionics suite, you will need a mechanism which can transmit these pictures back home, right? If you have something which is transmitting high definition live video back home, you'll need a very powerful data link, which will be heavy and will require large batteries. So the objective of this was just so that you select a very basic data link that can transmit a picture every minute. But there is no loitering required. The aircraft will be in motion while capturing these photographs. I hope that answers the question, Vayugati. Yeah, okay, you've said thank you. Arid Lead has a question. What must the preliminary design report encompass? This has already been shared with you. You should go through the NACDeC. Professor Pant, can you please confirm this? This has been shared already, right, with the students? Sir, you're on mute if you're here.
Ma'am, are you asking about the problem statement?
Yeah, in the problem statement, there is a section, right, about...
Yeah, it is already available uploaded on our website, so
Yeah,
students
okay.
can go through it.
Right. So please go through that on the website. The next question is, will the UAV follow a straight line path adjacent to border or precisely track all curvatures of the border? You have to track as precisely as possible all the curvatures of the border. Otherwise, then you would just directly connect the launch point to the end point, right? That's not acceptable. So it has to follow the curvatures of the border.
Sorry. One small point.
Yes, sir.
You have to follow all the points on the border, but you have to be inside the Indian territory slightly.
That's correct.
Otherwise, you will be shot down
Yeah.
by our friendly neighbor.
Then it's an airspace
So,
violation.
yeah. So you are supposed to be in Indian airspace, few, maybe 100, 200 meters, but follow the border.
Yes. Okay. Any more queries? Yeah, there's one more. How specific do we need to be about the avionics, sizing, and power parameters? As in, do we need to choose specific parameters from, for example, the manufacturer's description, or will a general rough estimate do? It's recommended that it should come from a manufacturer's description. Please try to be as realistic as possible. And in case, in fact, you should also look at 2 or 3 different manufacturers and then average out the values and use that if possible. The next question is from leader Udan. Can you explain more about the beyond the visual sight thing? Do we need to provide proper details regarding its control there? Yeah, the answer is, see, beyond visual sight means the aircraft is being launched from its home location. At its home location is where the pilot sits, and the pilot gives controls from the home location, or the operator is looking at the images at the home location. Now, visual line of sight means having a direct data link. But when we are talking about such large distances, you may or may not directly have a line of sight with the aircraft. You may not be able to see the aircraft from that point on the ground because of the Earth's curvature. Because of the Earth's curvature, if the aircraft flies below the Earth's curvature, it goes out of the view. In this case, what you need to do is provide a small satellite link, which can provide control and this 1 image per minute back home to the crew sitting in the ground control station. That's the meaning of beyond visual line of sight. I hope that clarifies this.
Tanvi, what can be done is, this is an area where we can have a separate webinar in case at a later date. They don't have, it's not required in the initial concept report, I think.
Yes, yes.
But we can,
Not
it's a
very
good thing to know, so we can
Right.
request an expert to talk on this.
Sure.
A very good point.
Sure. Vyom Kriti Lead has asked a question. Do we need to account for the battery usage by the EOIR turret during flight? Yes, you need to. That is the whole intention of asking you for the avionics suite. If suppose your aircraft is completely battery powered, this is a very good question, because some people might choose to have a fuel powered aircraft. Some might choose to have a battery powered aircraft. If you have a battery powered aircraft, please make sure that you have enough power both for flight and also for all the avionics that you're carrying on board. That's the whole point of the avionics suit. Again, I said size, weight, and power. So the power comes into the picture here. So that power can be used to estimate the size of the battery. I hope that answers the question. In fact, I would like to extend that a little more and say that even if your aircraft is not powered by a battery, if the forward flight is by an IC engine and not by battery, even then you will have to have an onboard source of power for all your avionics. So let's say your avionics require 100 watts of power at the end of it. You have to also allow for a source of 100 watts of power on board. It could be a battery, it could be an alternator on your engine, it could be whatever you choose. So yeah, I think we've addressed all the queries so far. Utkarsh Lead has raised their hand. Please unmute and ask your question. You have unmuted, but we can't hear you. No audio. Can anyone else hear Utkarsh?
No, we cannot.
Okay. Okay. Then in the meantime, there's another question from Leader Dhara. Does the EOIR have a normal imaging camera, and can we have a bit more details like the manufacturer and specs? This is something that I would ask you all to go ahead and read. The weight class of this has already been given to you. It's a normal imaging camera. Of course, EOIR stands for electro-optic and infrared. So it has both an optical range camera as well as an infrared camera. So please look for what manufacturers are there out there, and you yourself will be able to find these. the information is freely available on the internet. But anyway, I would also like to tell Team Dhara that you don't really need to know this. I mean, yes, for the power calculation, you need to know this, but the size and weight has already been given to you. So, Utkarsh, maybe since you could not unmute yourself, you can type your query.
Hello, ma'am. Am I audible now?
Now you're audible. Yes. Go ahead.
Ma'am, if we are going with the configuration of battery operated UAVs, so ma'am, the new technology like solid state, which are having more kilowatt per hour density. So can we go with that or conventional only what lithium ions are providing, that only we have to include in our report? Like to have an endurance of 9+ hours. So can we use this solid state technologies and all, which are from this year it started emerging in the mainstream areas?
So you have to be able to justify that it has been used. To the best of our knowledge so far, there are no commercial UAVs that are using this. They are mostly in the testing phase still. They are in R&D and development yet. And you understand that this Thar UAV is being made for border protection. So you cannot use an experimental UAV for this. So think of the conditions that you are going to fly in desert conditions, etc. These are extreme conditions. These new batteries may not perform so well in these conditions. So I think the short answer is please try to avoid these kind of new technologies in batteries. Stick to lithium ion, lithium polymer where you can.
Thanks, ma'am.
Okay, there are more questions from. Yeah, there's a Vayu Gati has also said, is it possible to be given access to the previous winning team's reports through the common WhatsApp group? Professor Pant, can you take this?
The answer is no. The answer is no because there are copyright issues, and many of the teams who have done the work, they are actually writing papers on their work. So unless the papers are published, that information is confidential. Okay, so we will not be able to share the reports of the previous teams.
Okay, thank you. Okay, team leader Shena has a question. Do we need to consider existing engines and choose the one which meets the requirements approximately, like the existing one which might be overperforming or underperforming? Yes, the answer is yes. As a designer, you always need to work with engines that are already existing. You are designing an aircraft, not a new engine. So please be practical. Pick engines which are already available. Do a survey of all the engines available in this power class that you require, and select one of them. Of course, you should not select an underpowered engine. You will always select an overpowered, equal power or overpowered engine. I hope that answers it. Okay, there is Garud has asked a question. Do we need to incorporate the avionics suite management and calculations in the preliminary report, or is that to be done at a later stage? Look, this information is available on the website. Please refer to the problem statement on the website. Aero Thar.
Also, Tanvi, before you go ahead, Tanvi, I have made several requests for people to rename themselves. And this team Garud, GEU, they are not renaming themselves. Please follow the protocol. Look at all the participants. They are, most of them. There are some people here, they are just having their names. So if you are not following a convention, next time we will kick you out of the meeting, and then don't feel bad because then you can't come inside the meeting. You have to follow the naming convention, please. Go ahead.
Okay. Aerothar has asked a question. The EOIR scans 3 kilometer radii by the camera. So in case a target is spotted at the edge, is the platform expected to reach it and drop payload like a bomb on top? Or the neutralizer dart will be launched in a trajectory without needing the drone to deflect from path considerably? The answer is the latter. Don't worry about whether it is in the edge of the camera or whether it's straight in the middle of the camera or where it is. Don't worry about that. Assume that the camera is spotting something which is on the line that the aircraft is following on its own trajectory. The drone does not need to deflect from its path considerably. It will be around, I mean, you don't have to, for example, make a big like 2 kilometer or 5 kilometer turn which will deviate from the path. It will be just a small correction to drop the aircraft, drop the projectile. The next question is again from Utkarsh. Will we be provided any format for preparing preliminary design report? The answer is no. Aerothar has
Tanvi. There is no
But
format, but there will
number
be
of
guidelines given. There
number
will be
of page
guidelines given. No, page limit, what font to use, all that will be specified. So every year we do that. We will share a document, but not immediately. We will share a document, but we will not say that do this or do that. We will only give you formatting guidelines. That we will share. We
Okay.
will share that.
Okay, there is a request from Dhara. Can we have a session or webinar on understanding adverse climate parameters for UAV design, specifically on design methods in such adverse conditions?
So
Professor
it's a
Patel,
fantastic question, and we have a student in IIT Bombay who is working on a seminar on this exact topic. So, at the end of the semester, when she has her report, we can request her to give a presentation. It's possible. So, we are ourselves researching this topic. So, we can try. We can try. But how is it relevant to the problem statement? And also, how is it relevant to the. See, in any design problem, you need to look at the low hanging fruits first and the things which matter the most. All the questions are only regarding the EO pod and all that. The other things, and in the DCE examination, people cannot even calculate the endurance properly, and they're talking about all these things. So, I mean, I think you are barking up the wrong tree. You are putting too much effort in second order problems. First, try to crack the basic aircraft design problem, and then look at these additional items. That is my suggestion to you. Okay, go ahead. We would like to wind up by 8 o'clock, unless
that's
there
it.
are very
Another
strong
5
questions.
minutes. Anyone wants to put in some final comments or final questions for us to address?
There are a few mentors in the meeting. If they would like to speak on how it is going in their own institutions, and if they are facing any issues or if they have any suggestions regarding the timetable, schedule, this will be a good time for us to do a mid-course correction if we can, and if it is needed. Because the competition is not for us, it is for you. So if you have any suggestion or any comment regarding the competition, yeah, there will be a format for all the reports. You will be given a format for all the reports. Every year we upload it, and we will upload it this year also. Is there any cause of concern by any of the mentors or the team leads about the way the competition is going?
There's a question. We have optimized and worked with more efficient figure of merit and endurance of a UAV. Is it okay, or we have to move on only with requirement? I mean, you
Okay,
have
can
been
I take
given a
that question?
set of specifications. As long as you meet these specifications, it's okay, I guess.
Yeah, but see,
Thank you, ma'am.
while meeting specifications, if you can do some optimization, if you can, but if there is a figure of merit given and if that can be optimized, definitely better. See, we are we look for feasible solutions, but we appreciate optimal solutions. But then who decides what is optimal? Unless there is a clear cut objective function given, okay, we cannot optimize. So if you have not been given Then the most common thing in aerospace engineering is minimize the weight, aircraft weight. That is what we all do. So all things equal, the lightest aircraft definitely is better.
But a figure of merit has been clearly defined in the problem statement.
Then of course you have to optimize that. So we will look at all feasible aircraft. So Vyom Chehak has a question regarding how to do sizing of a battery powered UAV. Well, this particular how to conduct weight estimation for battery powered UAVs. I don't want to spoon feed you. You have this competition is not held in a week or 10 days. It's not the hackathon type thing. You have enough time to look at it. I think you should first do your homework. If you have questions, you have a WhatsApp group, you have a email address for individual queries. Around what date the format and guidelines would be all told? You want it tomorrow, I'll give it tomorrow. The document is ready. As I said, it is used every year. We just have to put it up. But are you already ready with your solution? We are on 3rd of February. If you want, we can upload it. I have no problem.
Okay, there's a question. Questions are still.
Yeah, I saw that. I saw that question.
Achieving 9+ hours at 3000 meters with a 15 kg payload demands an extremely high fuel fraction. In your view, how would you typically approach the empty weight budget for such a platform, especially the trade-off between structural weight saving, composites versus propulsion reliability in dusty conditions where the maintenance access is limited? It's a very good question, very well thought out. There are two questions which you have asked. One thing is reliability of propulsion systems. I would say for this application, you don't need a highly reliable propulsion system. It's just a border protection kind of application. So it's possible to maintain a small fleet of these and have and fly these. So don't worry about propulsion reliability. Don't go for a very, very sophisticated engine in this category because that will add unnecessary weight. Now, where weight savings is concerned, yes, of course, you should use composites. There are ways in which composite airframe can be factored in to your empty weight fraction. That's it. So it looks like you all have already put some thought into this. So it is a problem. It is a challenging problem.
That's right.
Aerothar,
This is exactly the challenge. You have actually just highlighted the challenge in this problem statement.
yes.
So please solve it. Try your best to solve it. We will definitely give you feedback and comments later. But please try your best to solve it. Spend time searching for information on how to do it. There are many battery powered aircraft. In fact, a battery powered aircraft has already flown with passengers also. That means information should be available. And I can guarantee to you it's available.
Right.
Please search.
Okay, there is a question. I mean, Aerothar has said that turbofan explicitly was not mentioned. Yes, it was not mentioned explicitly, but the SFC was given to you. And from the SFC, it is possible to deduce that it was a turbofan. You all have data available. It was not based on engine control unit or anything like that. A turbofan engine and a prop engine will have wildly different SFCs. So looking at the SFC number, you should be able to tell that it was a turbofan. Okay. Anyone else? Looks like that's it. If there are
Yeah,
any
and
more
time is
queries, you all should send it over email or WhatsApp. Many channels are available, so our time is up. I think we should
yeah.
close.
The only thing that I would like people to avoid is sending a direct message to any of us. That will be taken with very serious breach of privilege. There are people who are sending messages to individuals, and so far we have been liberal, but I'm announcing it right now and it's on record. If any team approaches any team member individually for any advice or guidance, apart from the two modes, the email and the WhatsApp group, we will view it very seriously. So on that note, I think we should say goodbye. It's already 3 minutes past 8 o'clock. We are happy that Several teams have joined the webinar and they have expressed their concerns. If any team is dissatisfied with the DCE results, they are welcome to send us an email and we can arrange for a special online consultation where we can try to go through the paper with you and tell you where we think you have gone wrong and why we think that you have not obtained the required competence, unfortunately, despite so much time available for you. Okay. So we are very much open. See, we don't want to reject people. We are happy if all the teams continue. But we do this DCE because we want to minimize or optimize our evaluation time. Because this whole activity is done by volunteers. We have our own full-time jobs and a lot of our jobs, we have lots on our plate. So we don't want to spend time looking at frivolous teams who have just registered because someone has told them or because there was a pressure from the department or the director or the HOD. And if you have not been able to acquire basic competence in about 1.5 to 2 months, then the projection is that you are going to give a frivolous report, perhaps a copy paste from somewhere or perhaps an AI generated report, which we would not like to get. But if you think we have erred, we are open. Please send a mail. We will fix a meeting and we will have a discussion with you. Okay. Everybody can make mistake. We also can make mistakes. We may presume that we may have misunderstood. Don't worry, it's not about marks only. We have not done this evaluation based on, okay, if you are getting 12 marks you are out and 10 marks you are in. It's not based on that. It's based on a very critical review of all the answers and our assessment on what you know, what you don't know. Okay, so with that, I would like to wish you all a very good evening ahead and I'm going to stop the meeting. Thanks a lot.